Hello everybody. So in today's video we're going to go over simply Respiratory Objectives 1 and 2. Respiratory System Objective number 1 is list the organs an oxygen molecule encounters as it travels down the respiratory passageway and into the bloodstream. Objective number 2 is relate the structure and function of each of the following: nose, parasynal cavity, sinuses and cavities, pharynx, and larynx. Right? So first, we're going to, this is basically your introduction to your respiratory system. We're going to talk about the organs and pathways involved, trace how a molecule of oxygen would travel going from outside world into your body as it hits your lungs. And we're going to talk a little bit about your upper respiratory system, because there is an upper and a lower respiratory system. Right? So first, let's do our introduction to organs and how oxygen travels. We all know that the primary function of your respiratory system is going to be oxygen and carbon dioxide transport both in and out of the body, respectively, as well as exchanging carbon dioxide and oxygen for your blood. We all know that primary function. A secondary aspect of that would be acid-base balance within your body. We will get into that later this unit. And secondary functions also kind of include your ability to talk. Speech production has to travel through your airway and your voice box. And sensing odors, like your sense of smell, which greatly also impacts your taste. So those are kind of secondary side effects of your respiratory system. Right? We can kind of summarize the different jobs of your respiratory system by either referring to them as a respiratory zone or a conducting zone. Conducting zones are the tubes where air is traveling, essentially. Their job is to regulate the temperature of the air, making sure it's not too hot and not too cold, because your lungs are a little bit like Goldilocks, and they will collapse if it's too hot or freeze if they're too cold, and no one wants that. They're going to catch and remove some pathogens, deal with humidity, all that kind of good stuff, as far as breathing in and out goes. Respiratory zones are the areas that are directly involved in gas exchange between your lungs and your bloodstream, that kind of thing. So we'll get into the respiratory zones much later on. In y'all's note-taking guide, you've also been given a lovely little black and white picture, so you can label things yourself and color in, right? And here we go. The first thing here, you have your nasal cavity, right? This is where you breathe in through your nose. Your nostrils, right there, are first and foremost, and then you have a lovely nasal cavity. You can also, however, breathe through your mouth. Some of us do this when we're asleep and we're snoring. Right? So you also have the mouth and the lips and an oral cavity here. Both of these cavities end up meeting your pharynx. The pharynx is the tube that carries both air and food down your throat to this place in your body where either air or food need to go through their respective forks in the road to get to either your lungs or stomach. Right? So your pharynx is the tube back here that travels down to your voice box or your larynx and your esophagus. So it starts at the back of your nasal cavity and it dead ends where your esophagus and larynx begin. That tube is called the pharynx. Right? We are talking about breathing in air, not food, so we're going to follow the path of air. The proper term for your voice box, and we'll get into more specific anatomy with your voice box in a little bit, is called the larynx. These are where your vocal cords are housed, and it is the beginning of your internal respiratory system. Everything that we have talked about so far, from larynx and up. So that's your larynx, the back of your throat or the pharynx, nasal cavity, nose, oral cavity, and mouth, all of that is your upper respiratory system. So if you've ever gone to the doctor and they say that you have an upper respiratory system infection, it means that you have an infection somewhere from your larynx up. It could be your nasal sinuses or perisinal cavities. It could be in the back of your throat. It could be tonsils up here. That kind of thing. But this is all your upper respiratory system right up here above your larynx. So we know that when we breathe in, your oxygen is going to travel through the nose, nasal cavity, down the pharynx, and into the larynx or your voice box. Your larynx is then going to send the air, the air is going to be pushed by your inhaling and exhaling further down, and it will go down a tube called the trachea. The trachea dead ends where your primary bronchi, or the bronchial, or the singular of bronchi is bronchus, bronchi is plural, but you have one primary bronchi going into your left lung and one primary bronchi going into your right lung. The trachea dead ends at a location called the carina, and after that, air is going to travel through the primary bronchi, and then your bronchi is going to start branching like trees, right? Like tree limbs. There's going to be multiple turns in the road, multiple branches. All you do is you count the branches. So the primary bronchi is first. One turn later, where there's been one fork in the road, is called a secondary bronchi. And then you end up at the end where there are tertiary bronchi. And then after your tertiary bronchi, you're going to end up at the smallest tubes called bronchioles, terminal bronchi, and the terminal bronchi are then going to join tinier vessels called respiratory bronchioles. So you have your terminal bronchioles leading into respiratory bronchioles, which then lead to little air sacs that look like little bunches of grapes, right? Called your alveoli. Each grape is called an alveolus, plural would be alveoli, and the whole little bundles of them or bunches are called the alveolar sac. And these respiratory bronchioles travel to the alveolar sacs with an alveolar duct carrying air to each and every alveoli, and the little capillaries that line the walls of the alveoli is where gas exchange happens between your blood and the air that you have breathed in. Conducting zones are everything from your mouth and nose all the way down to your tertiary bronchi. Tertiary bronchi is the farthest down bronchi that your lab list lists. Everything after that point, the terminal bronchioles and the respiratory bronchioles, are considered part of the respiratory zone instead of the conducting zones. So conducting zones are air entering you down to the bronchi. The respiratory zones are bronchioles on. Everything that is south of the larynx, so the trachea, the bronchi, and anything deeper into the lungs is a lower respiratory system organ. So that would be your lower respiratory system. If you're told you have a lower respiratory infection, that's something like bronchitis where your bronchi are infected. That is further south than your larynx. The muscle that controls all of this and enables you to breathe is this larger muscle that goes from rib cage to rib cage, like across your entire abdominal cavity. It's the top of your abdominal cavity, called the diaphragm, and it separates your thoracic cavity from your abdominal cavity. This lovely diaphragm muscle is responsible for your ability to breathe. And while we will get into this in another video, right? You have the lining of your lungs are called the pleura, which is why your lungs are found in the pleural cavity. And you have some airspace and some space in that cavity to help you breathe. We will discuss how pressure in these cavities affects your ability to breathe and makes you breathe in later videos. But you should know that your lungs are found in the pleural cavity, and the outer, the tissue around your lungs is called the pleura. Remember your difference between parietal and visceral. Visceral pleura is going to cover the lung surface and touch the organ because it is visceral. Parietal pleura is going to be the outer covering, that is going to be the outer covering of your pleural cavity that touches other organs. Like your parietal pleura here is probably also going to be touching the parietal pericardium because your heart is found happily right here in this lovely little space for it. Right? Now knowing all of that, we've listed all of them, if we are listing the organs specifically that oxygen will travel through going in and out, right? Oxygen will come in through your mouth or your nose and then go through nasal cavity or oral cavity, go down your pharynx, into the larynx, past your vocal cords, down the trachea, through the primary bronchi going into your left or right lung. We're going to go right here. So primary bronchi into the lung, secondary bronchi, tertiary bronchi, down into the respiratory zone of your terminal bronchioles, and then your respiratory bronchioles, and then the alveolar sacs into an alveoli. And then that is where that oxygen will be exchanged via capillaries to a red blood cell. And then carbon dioxide will follow the same path in reverse. From the alveolus through that alveolar sac into respiratory bronchioles, terminal bronchioles, tertiary bronchi, secondary bronchi, primary bronchi, trachea, larynx. You may be even speaking and making it vibrate your vocal cords as you push this air out. Pharynx, then oral cavity, mouth, or nasal cavity, nose. Right, that would be your first objective. Right, and then your second objective, we're going to talk about the structure and function of your upper respiratory system. It's pretty straightforward, right? So your nasal, we all know what our nose looks like. Our nostrils are to breathe in air. We have ridges on the inside of our nasal cavities called nasal conchae. Those individual ridges are to increase surface area. Your nasal cavity also has hairs lining it, right? And it is also lined with mucus, right? That mucus and those hairs are going to catch dust and germs that you may breathe in. That is part of your immune system, guys, remember? So those conchae are going to disrupt airflow. So air is going to bounce around the epithelial tissue in your nasal cavity. This is why when it's cold outside, that those conchae are there to warm up the air so you're not breathing in cold air, because your lungs, remember, are somewhat like Goldilocks. They don't like it too hot, they don't like it too cold, and your body is going to protect itself because your lungs are delicate. Because of that nasal cavity wants to warm up the air or cool it down, get it to the right temperature for you to further inhale. It's going to get it to the right warmth and humidity levels, and it's going to also catch pathogens that may come in. You have goblet cells in there that make mucus. All of these, your pharynx, nasal cavity, nostrils, all of this area here have goblet cells that create mucus within their pseudostratified columnar cell tissue layers. They all have lysosomes in them, so they're going to be ready and willing to digest and kill off pathogens that may come in. You're going to have lots of immune system recognition around in this area as well, and defensins. Right, so why does cold air cause a runny nose? Because your body is trying to warm up that cold air as fast as you are breathing in so your lungs don't get hurt. So all of this region of your respiratory system is kind of going to go into overdrive in an effort to warm up that air, and you're just going to make more mucus as a byproduct of this as well, because all these cells and epithelial tissues are going to go into overdrive. The pharynx is divided into 3 separate regions dependent upon what region it's behind. Your nasopharynx is an airway that is the back of your nasal cavity, where it's the pharynx at the back of your nasal cavity, right? Your adenoids or pharyngeal tonsils are up there. It's just above your adenoids would be around where my mouse is right now. If you open up your mouth big and wide, they are just above where you can see. So you cannot see your adenoids when you open your mouth. When you swallow, you guys have looked in the back of your throat in the mirror and seen that little thing that dangles down at the back of your throat. That is called your uvula. And that is a flap of your soft palate. It tries to act like a valve, but it is not airtight. Its job is to push closed when you are swallowing food in the hopes that food or water will not backwash up into your nasal cavity. This is why with small kids, if you make them laugh while drinking milk, as that old school time adage goes, they can milk can squirt out their nose, because if you make someone laugh while they're trying to swallow, sometimes things backwash up there. Your uvula, this little flap, also attempts to shut in the event that you are sick. So when you are throwing up, it attempts to close again so that everything you are throwing up will come out your mouth. Sometimes that is not the most accurate or airtight thing, and you end up with that burning sensation in your nose, in your nasal cavity, because of the stomach acid, and your nasal cavity is not built to withstand your stomach acid. But that's the purpose of your uvula and that flap there. The next area down of your pharynx would be the oropharynx. That is where food and air pass through, because that's the back of your oral cavity. That's also where the lingual tonsils at the base of your tongue and your palatine tonsils, which are the ones you can see at the back of your throat when you open your mouth big and wide, can be found. A little bit further down, you have the laryngopharynx. This is the end of your pharynx, and it's the region that is right behind the beginning of your larynx. This is essentially where food and air detour from one another. Because when you are swallowing, food presses against this flap here. This is a cartilage flap called the epiglottis. When you swallow, things push it down and closed, and then the food goes down past the laryngopharynx into the esophagus and then down into the digestive system. Whereas when we are breathing, this flap stays open and air can just travel through here happily. Right? So that's the purpose of the laryngopharynx region. And then you have your larynx. This is basically a view of what your larynx will or would look like if you ever had to put a camera down here to see if anything had been swallowed or done damage. There's lots of little cartilage pieces that create your larynx. You guys know about most of these now from lab, right? But your larynx, it is a cartilage region that connects the pharynx to your trachea. Its job is to help separate, make sure only air gets down into your only air gets down into your trachea and all the food ends up in the esophagus, which is why the epiglottis here is part of your larynx, right? The epiglottis was that flap that closed to make sure food didn't go down your windpipe, essentially. The larynx's job is to regulate air volume entering, and there are a number of cartilage pieces that build this. Right? So you have the thyroid cartilage, because your thyroid gland is sort of wrapped around your voice box or your larynx right here. On all of your models in lab, you will see a thyroid on these respiratory models. Then you have the cricoid cartilage, and then tracheal cartilage rings going up and down the trachea, and you have ligaments connecting them all. So the cricothyroid ligament is between your cricoid and thyroid cartilages. Cricotracheal ligament is between the cricoid and tracheal cartilages. Thyrohyoid ligament or membrane is this ligament between the thyroid cartilage and your hyoid bone, which is the bone that your tongue anchors to. And then the epiglottis is this cartilage right here that will close and that opens and closes to allow food to pass and then air to get in. Right? So you have a number of various pieces of cartilage. If you are looking down, this is the view you're going to see. So you can see the epiglottis in this protective tissue here. You can see vestibular folds or false vocal folds, which are it's the thicker protective skin around. And then you see these lighter, softer vocal folds or true vocal cords. Those are your vocal cords. Those vocal cords vibrate as you push air past them, and how deep your voice, just like guitar strings. You guys have all either played a guitar yourself, or you can Google a video of someone plucking guitar strings. You know that the deeper sounding notes, so the deeper notes, the lower ones have slower vibrations, and you can see the guitar string vibrate slower. And then the higher notes have faster vibrations on guitar strings. That sort of gets into the physics of sound waves and that sort of thing, which is, I'm not going to harp on that too much, but your vocal cords do the exact same thing. So the higher pitched your voice is, the tighter you are stretching your vocal cords. And the lower your voice is, the slower your vocal cords vibrate, or the thicker they are. This is why people have different pitches and different voices, and people who are really good at singing are really good at using the little muscles around in that area and tightening that skin or loosening that skin so they can hit a far better array of notes than I ever could. I play musical instruments. I cannot sing. Y'all don't want to hear that. However, Mariah Carey can loosen or tighten her vocal cords so she can hit ungodly high notes. We will all know about this soon enough when the Christmas carols hit the stores, and we can listen to All I Want for Christmas Is You on repeat, especially if you're one of my students that works retail. I'm sorry. Right? But that covers your first 2 objectives for the unit. Keep an eye out for the next video, and we'll cover a few more. Have a wonderful, wonderful day, and I will see you soon.